Take a look at the shell of the turtles. I can see they're made up of a number of regions, and if you look at those regions, they have very straight boundaries. It's always a little surprising when we see a straight line in nature, isn't it?
True. There aren't many straight lines in my face, for example, yet we see surprisingly straight lines in this biological creature. In fact, if you look at some of the turtles, you'll see that they have an almost perfect regular hexagon right in the center of their back. I wonder where those shapes could possibly be coming from.
I think I've got it. What happens is each of those regions grows at a constant rate. And so that tells you that any part that's on one of these regions has to be closest to the center of its plate. Because if it wasn't closest to the center of its plate, another plate would have gotten there first.
Okay, so each one of these plates consists of all the points that are closest to where that growth began. You know, we actually see this pattern over and over again in nature because there are many cases in which things start growing from multiple points and they grow until they meet, and then you get a straight line boundary.
Like the coat of a giraffe or a honeycomb.
And what is the locus of all the points that are equidistant from two given points? The perpendicular bisector of a straight line.
I was about to say that.
Sure you were. So we see this principle from geometry showing up in living things. This is the surface of something which grew in the same way. Started from many points, then grew at an equal rate. They met, created these regions, which have a fancy name. They're called Voronoi regions, but that doesn't matter. They're just the regions of things that are closest to its growth points. Want to guess what it is?
It's either a hedgehog, a pineapple. Oh, no, it's celebrity chef Guy Fieri.
Truly not even close. This is the rind of a spiked durian, which is a smelly kind of fruit. But this is exactly how it grows, just like the turtle.